Hello students, today in class I gave you this problem to do as a warm-up to help us think about integrating and the need to integrate with completing the square, and I did not do a very good job of explaining integrating arctan, and so I wanted to come back and do that again. So let's start with our derivative rule that we had, that was the derivative of arctan is 1 over 1 plus x squared. Well, let's remember where that came from. That came from the idea that if I had some function y that was the arctan of x, then I could say that tan y was x, and that led me to a triangle with an angle of y, an opposite of x, an adjacent of 1, a hypotenuse of 1 squared plus x squared. Psst. The derivative of tan is secant squared y dy. Derivative of x is dx. And I'm leaving it this way to help think backwards with my integration. Secant of y, well, that's the opposite of cosine. So secant y is square root of 1 plus x squared, but then secant squared would be 1 plus x squared. Dy is dx. Dy, 1 over 1 plus x squared dx. So now if I integrate both sides, then I know that the function that has this as its derivative was tan inverse. And then I would have a plus c if I had integrated. So let's see what happens when we have the integral of 1 over x squared plus a squared. Well, in this case, I should have thought about my trusty friend, the u substitution. I know the integral of this, so I don't want an a squared there. I really want a 1 there. So I'm going to rewrite that by factoring out that a squared, and then I'll get x squared over a squared, which is x over a squared, plus 1 dx. And now this is good because it's looking like u squared plus 1. So I'm going to have my u be x over a. My du then is going to be 1 over a dx. Well, notice I have 1 over a squared. So I can replace 1 over a dx with my du, but I'll still have 1 over a left over. So a squared is going to separate. I'm going to take one of them to be my du. So I'm going to have a 1 over a left over times 1 over u squared plus 1 du. So notice that this 1 over a is a constant. Whatever that number was up here, it's just a number. So I can factor that out. I'll get 1 over a, integral of 1 over u squared plus 1. Well, I know that that is just going to be arctan of u plus c. Well, I can go back then and say that originally that u value was my x over a. So if we come back to this problem that we were looking at today, at some point we ended up with having the integral of negative 16 over x squared plus 3 dx. Well, I'm going to bring this negative 16 out to the front. Integral 1 over x squared plus 3 dx. Now you can either just straight away use this pattern and know that 3 is the same as square root of 3 squared. Dx. And so I can say that, okay, root 3 is my a, so that's going to lead me to negative 16 over root 3 tan inverse of x over root 3 plus c. Or you can again factor that out So I would get negative 16 integral 1 over 3 x over 3 root 3, goodness, squared plus 1, 3 times that whole thing. So when I do my u substitution, u is x over root 3, du is 1 over root 3 dx. If you wanted to substitute it the other way that we've learned, I could say that dx is the same as root 3 du. So now I'll come in and replace dx. So I'll have negative 16 times root 3 integral 1 over 3 u squared plus 1 du. But notice that root 3 over 3, well, that's the same as negative 16 over root 3, because this is root 3 squared. 1 over u squared is tan inverse of u plus c. I hope that helped. Please feel free to come talk to me, and I can break it down for you some more if you need that.